Hello, welcome to Tech Talk with Steve, episode 51, new test capability. Ooh, mystery topic. What could it possibly be? I'm Steve Cowles, your host, product manager with AEM, and we're going to be talking about some new testing capability today. So what could it possibly be? Could it be fiber optic with hybrid powered fiber capability? Nah, we've had that forever, so it's not that. Could it be single pair Ethernet? No, we've had that. So it's not SPE. Could it be coax? No, we've had that for a while. Patch cord testing? No, we've had that for a while. What else could we have in a certification multifunction tester or qualifier? Multi-gig and PoE? No, we've had that for a while too. So what could we possibly be talking about with a new test capability? What could we possibly add to a multifunction certifier or multifunction qualifier that could make it even better? I'm going to share my screen and we will get to the bottom of our little secret. So we are going to be talking about Restream. Okay.
Hey, Steve.
Can you hear me?
Yeah, we can hear you. For some reason, we just lost your screen share, but you're back on now.
Okay, so you got my screen share again?
Yep.
All right, we should be good to go. All right, so OTDR, optical time domain reflectometer. That's what we're talking about today. So hopefully everybody can see me and hear me now. Sorry for the little technical glitch. So let me get into the meat of this. So before we talk about the OTDR itself, I want to talk a little bit about Tier 1 fiber certification versus OTDR fiber testing versus Tier 2 fiber certification. Still seems to be a little confusion out there. So we just want to, put a level playing field here before we talk about the product itself. Tier 1 certification is optical loss testing. And in its simplest form, it's just a comparison between how much power you have at the output source, the laser or the LED at one end, and how much power you get at the far end of a fiber that's connected to that source. Way back in the day, we just used a handheld light source and power meter. We'd take a measurement with a reference cord between the light source and the power meter. And then we would take that power meter to the opposite end with another reference cord and we'd connect to the fiber we were testing. We'd take another reading. Then we had to do math. We'd calculate how much loss we had from one end to the other by subtracting one reading from the other. As testers advanced, we had standalone light sources and power meters that had a zero reference or a set reference. So you could zero that out, go into dB instead of the dBm power mode and measure the loss. So you'd set that at zero and then you'd go to the opposite end and hook up. It would just tell you how much loss you had. But again, it was a very manual process. Then along came optical loss test sets or optical loss test systems, depending on how you want to refer to them. And that's what we're showing as the example on the right, where you combine the light source and the power meter, and you're measuring against standards and providing a pass-fail. And that's known as an optical loss test set. And that's a bidirectional test or a dual-ended test. It could be bidirectional or single direction, depending on your scope of work. And the way that it was set forth for your certification process. And it weights it against the standard that you choose in your test setup. And then it gives you that pass-fail based on the length and the loss and the delay. So what is OTDR testing? And what is an OTDR? So OTDR, optical time domain reflectometry. When we're talking about the equipment, it's an optical time domain reflectometer. And basically what it's doing is it's sending a pulse of light down that fiber and it's looking for reflections. And when there's a reflection, it's going to send part of that signal back. And what the OTDR does is it measures how long it takes that signal to return to the source and how strong that signal is when it gets back to the source. So it'll compare that relative to how strong it was when it was sent out. From that bit of information, it can determine how much reflective loss you're going to get at that event that caused that pulse of light to be reflected back, and how far away that event is. So think about it like it's like sonar. If you've ever watched any of the old submarine movies where you hear that ping and then there's a response ping coming back, if you're a big Hunt for Red October fan, one ping only. So what happens with a sonar ping, they send it out, and based on how strong that return is and how quickly that return comes back, they can tell a lot about the enemy vessel, how far it is, how big it might be. So that's exactly what we're doing with an OTDR, but it's a pulse of light, and we're using it to look for issues along the fiber. So it's commonly used, OTDR is commonly used for troubleshooting. So if you get an optical loss test that fails, the first thing you're going to do is you're going to inspect your connectors. If maybe you forgot to inspect them before you ran your test. So, one little note there, you should always inspect, clean, then inspect again to make sure it was cleaned. If you inspect and the connector's clean, don't bother cleaning it because it's good. And you should do this when you're connecting test equipment. You're connecting your test reference cords to test equipment. You should do it when you're connecting to a patch panel on either end. When you're connecting to run your test, you should inspect not just the connectors on those test reference cords, but in reality, you should be inspecting those connectors inside the ports of the panel that you're testing. So the reality situation is there's a lot that gets overlooked in an optical loss test, and 95% probably of troubleshooting calls that come in typically with a fiber test not passing end up being related to dirty fiber. And then there's a lot, that could be a broken fiber, but typically there's dirt or damaged fiber connector that's causing the issues. And yes, when you inspect, it takes time. It adds time to your process on the job, but it's the right thing to do. You should be checking your connectors whenever you're hooking up to run a test. So if that test fails and you inspect those connectors, the connectors all look good, you don't see anything obvious, you hook up a visual fault locator, which is built into our optical loss test adapters, to look and see maybe if you have a mechanical splice type connector, maybe it has a lossy splice, and you can actually see that light in that connector. Some of those connectors are tunable. And if it's a fusion splice, you're typically not going to have to worry about that. Fusion splicing is a much better solution than the mechanical splice connector anyway, but that's a whole different topic. We could go down a rabbit hole on that. But again, it's commonly used to troubleshoot. So you've used your inspection scope, there's no dirt, you've used a VFL, you don't see any obvious damage to the fiber, any obvious lossy mechanical splice type connector, you don't see a sharp bend on one end or the other that you could identify with that visual fault locator. So you're going to pull out an OTDR to kind of help troubleshoot and find what could be causing this loss event. Now, one note about an OTDR testing on its own is not considered certification, and it's not acceptable as a standalone test for the suitability of the installed fiber to support intended applications. Now, a little caveat there are some people that will swear by an OTDR test, and that's all they need to make sure that their fiber is good. And as long as you don't have any problems, then you can use an OTDR test to proof your cable and go, yeah, it's going to work for my application. But it's not a loss test. It doesn't give you all the parameters, and the loss values that you get from an optical loss test set are going to be much better, much more accurate than what you're going to get from an OTDR. So it's better to use an optical loss test set to do that kind of testing to proof it for future applications or current applications. So with an OTDR, the measurements you're going to get the length of the link, and we'll talk about that here in a moment. We're going to talk about the total link loss. So how much attenuation do I have along that entire link? The optical return loss. So that's the reflection that we're getting. Sometimes they'll call it reflectance, from the events for individual events and cumulative. And then the position of the elements on the link. So those are what we call events. Mated connectors. The fiber itself is going to have a certain amount of attenuation. You'll notice on an OTDR plot, as you go from left to right, it gets lower. That's the attenuation of the fiber. And then the spikes and the drops from the events are the reflective and non-reflective events. And then, of course, there's the end of the fiber or break in the fiber that contribute to that. Insertion loss of the elements is shown in the trace. So when we look at that, we'll see that loss along the fiber of not just the fiber itself, but each event as it adds to the fiber. So you can view each of those individually. And then you can, if you're using it for pass-fail, you can assign it as a pass-fail diagnostic with a pass-fail rating based on the limits that you've set. And we'll talk about that when we do the demo toward the end. And just to give you a little bit of an example of what we look at in an OTDR trace. So when to help analyze this, so in this case, we've got the start of the fiber right here. This part right here is our launch cord that we're using. And then this first spike is that connector where the launch cord mates with the connector on the end of the fiber under test. And we see a reflection there. And the OTDR will report back a value of that event right there. Here we see a splice. So a splice is going to show just a drop like that on the fiber, and then it continues. And we can see that this drop relates to dB over here on this side, which is loss. So with the connector, we're looking at loss. You come in on one side at one power level, we go out the other side, we're a little lower. That's the loss of that event. The same thing with a splice. There's going to be loss there. Now notice there's no spike with a splice because it's not really a reflective event. There's a little bit of reflection. That's part of how we identify a splice, but it's not a big reflective event. And a good splice offers back almost no reflection that's going to be discernible on the OTDR, just enough to identify where the splice is. A mechanical splice would probably show a bit more of a spike because when you do a mechanical splice, that is actually two pieces of glass that you're mating together, usually with an index matching gel, and then they mechanically get clamped down. And in that case, there's always two pieces of glass, whereas when you do a fusion splice, that's a single piece of glass as you pass through it, which is also why, incidentally, when I talked about mechanical splice connectors earlier, if you have mechanical splice connectors on two ends of a long fiber, you essentially now have three pieces of glass from end to end. That's why fusion splicing, either pigtails or fusion splice connectors, is a much better solution, because now once you fuse that, you essentially have one piece of glass from end to end, which equates to less loss and better performance. So here's another connector here. And then this looks like a splice. It could be a splice, a lossy one, but more than likely, it's probably a bend in the fiber. Those tend to look like a splice. Now, the way to identify what it really is you're going to want to look at the trace at two different wavelengths. So if we're looking at single mode, you've got 1310 and 1550. You would notice that in the case of a bend, the trace is going to have a lot more loss. There'll be a lot more drop in that little step right there that looks like a splice. It would drop much further in the 1550 nanometer wavelength than it would in the 1310. And that's how you can tell if you actually have a bend in the fiber. A crack would exhibit a reflection because, yeah, it's a cracked fiber. Could even be broken and it might just drop right off, but you will get a reflection because there is a reflection from that broken fiber. In this case, it looks like there's still a little bit of connectivity, even though it's cracked, and we see a lot of noise on the other side of that crack. And then we see the end of the fiber. Usually there's a big spike at the end of the fiber, which is your end connector. A lot of times that could be the end of our launch cord. Or our tail cord rather. And then you see just noise as it drops right off. It just drops down to the floor there. And these are the typical symbols you'll see on the OTDR indicating each of these events. So the reflective event symbol here shows you where you've got connectors. Maybe a crack or a break will look like that, the little spike. The start of the fiber is going to just be a vertical line with a horizontal line to the right. The end of the fiber is just the opposite. You can think about that as here's a connector end face, and then this line is the fiber continuing on from the beginning. And here we get to the end of the fiber. Here's fiber coming in, and that's the last connector. So that's the easy way to remember those. And then non-reflective events like splices or bends typically would show up with this type of symbol. And it looks a little bit like that drop-off that we see in the splice and the bend. So what is Tier 2 testing? We've talked about Tier 1. We've talked about OTDR. So what is Tier 2? We've actually had some people assume that Tier 2 testing is an OTDR trace all by itself, but it's not. Per the standards, Tier 2 testing supplements Tier 1 testing with the addition of an OTDR characterization of the elements along that fiber cabling. Simply put, Tier 2 testing is testing the same fiber with an optical loss test set, doing a Tier 1 test, and then an OTDR trace. So you can see from the graphic here that optical loss test plus the OTDR test equals Tier 2 testing. So that's the definition of Tier 2 in a nutshell. So before we talk about the OTDR, Jacqueline's going to go ahead and bring up a question, and you can comment in the comment section with your response to this. So true or false, Tier 2 testing requires both a Tier 1 optical loss test and an OTDR trace. This should be a pretty easy one because we really just talked about it. But again, Tier 2 testing requires both the Tier 1 optical loss test and an OTDR trace. So true or false. And we've already got somebody chiming in. So we'll look at these responses as people go ahead and comment here. We'll get a little further along in our episode here, and we'll come back to that question. So I'm going to go ahead and move on to my next slide here. We're going to talk about the OTDR. So the AEM OTDR is a modular design. So it allows adapters to be used with the TestPro or the NSA. It's the same type of modular test adapter that you've used for your copper testing, for your fiber loss testing, for your multi-gig and PoE, your single pair Ethernet. It just swaps right out, hot swappable, just like all of our other adapters. So existing TestPro users can add OTDR troubleshooting and Tier 1 testing. They've already got the optical loss test adapters for doing Tier 1. All they need to do is add the OTDR. Now they're ready for troubleshooting. They're ready for doing Tier 2 testing in case they need it. Existing NSA customers, Network Service Assistant, can add OTDR for troubleshooting. So yes, it will work not just with our certification multifunction tester, but also with our Qualification Plus tool, the Network Service Assistant. And as far as I know, it's the only qualifier out there that's going to give you an OTDR option. Maybe somebody else knows of one. Let me know if you do, but I think it's probably the only one out there. Prospective users who require an OTDR option in order to purchase or specify a certification tester now have that option with AEM. This is a feature, and the reason we've added it is people have been asking for it. So it's been coming for a while. We're finally here. So now, if you've been holding off on pulling the trigger on AEM because you needed OTDR, you've got it. So the OTDR is available in individual adapters, either multi-mode or single mode, so you can add it to your TestPro or NSA. There are also standalone OTDR kit configurations, and I'm going to go through these configurations real quickly in a subsequent slide. But those configurations will include a single TestPro handset. This gives you the flexibility that if you're just getting it as an OTDR, you can expand it down the road and add copper and fiber certification and smart building certification just by adding another handset, getting the certification license, and getting the necessary adapters. And on a side note, all of the handsets have a built-in gigabit Ethernet port for doing SNR, network discovery, and connectivity, also for test results upload. And you can add an Etamax USB Wi-Fi adapter for additional testing functions and uploading via Wi-Fi as well. So in those OTDR kit configurations, we've got a dual wavelength multi-mode kit, gives you 850 and 1300. We've got a dual wavelength single mode kit that gives you 1310 and 1550. We've got a quad wavelength kit with one multi-mode and one single mode OTDR test adapter. So you get the handset and you get a multi-mode adapter and a single mode adapter. Then we've got our TestPro Tier 1, Tier 2 combination kit. So this gives you optical loss testing and OTDR capabilities in 4 wavelengths. It comes with multi-mode and single mode adapters, so you can do 850, 1300, 1310, 1550 for optical loss tests and for OTDR. So it gives you that Tier 1, Tier 2 combination, or Tier 1 and troubleshooting, depending on whether or not you need to do Tier 2. And then our ultimate, the mega kit here, our TestPro Smart Building Max Kit. So this combines the TestPro K61E, if you're already familiar with it, our Smart Building Test Kit that gives you copper and fiber certification for Tier 1 fiber, gives you the copper certification up to Cat 8. It gives you the multi-gig and PoE test adapters and the network testing capability. And this takes that kit and it adds to it the multi-mode and single mode OTDR capabilities. Now, in both the tier 1 and tier 2 combination kits and the Smart Building Max kit, we also include a launch cord with those as well. So NSA, again, you can enhance your NSA by adding OTDR capability. It's the only qualification tester I know of on the market that gives you more testing functionality than a qualifier or any other validator qualifier in the market, with the Certolite test, the PoE testing, the multi-gig and PoE, wired and wireless network, fiber optic loopback, and then the full test reporting capability. And now adding OTDR capability to that adds another significant feature to your network service assistant. You can do all your troubleshooting. If you're having an issue with fiber, pinpoint the breaks in the fiber, find the source of your loss issue, bad connector, bad splice, a big addition to a qualification tester. So some of the specifications here, again, the wavelengths, 850, 1300, 1310, 1550 for single mode, event dead zone, 0.6 meters to 4.5, depending on the wavelength and what your pulse width is set at. Attenuation dead zone is 2.5 to 4.5 meters. Dynamic range of 25 to 27 dB, depending on which wavelength you're at. Distance measurement range, typically for our market segment that we really play in, most people are below 3 kilometers, but you could go up to 9 kilometers for 850, 35 kilometers at 1300. You can go to 80K for 1310 and 130K for 1550 nanometers. I don't see most of our customers doing that, but if you had to test longer fibers, you can. Pulse width, we've got selectable pulse widths from a drop down, but also user enterable pulse widths anywhere from 3 nanoseconds to 25,000 nanoseconds. So a lot of flexibility in there as well. Test results management and reporting. So, in your test details, you can see your trace. You can put a marker on there and scroll across the trace, and I'll show you that here toward the end if we have time. We've got OTDR test reports here as well. So just like all your other reporting you're doing, you'll have that capability built in with the OTDR tests. The kits, as I mentioned, are available in single kits with a multi-mode or single mode or both. That's our K21E series. You can get the adapters by themselves, the AD-OTDR SM or MM. And then the TestPro K41E is the fiber tier 1, tier 2 kit, and the K71E is that smart building kit along with the OTDR. So let's take a look at the question responses we've had here. A few responses. We got a true, we got a true, we got a true. And a reminder, that question was true or false. Tier 2 testing is a tier 1 test plus an OTDR test. And we've got a bunch of trues in here. Everybody really did get it correct. So everybody knows their stuff. So, so one other question that we'd like to go ahead and pull up now is true or false. You can add OTDR capability to the TestPro or NSA by simply purchasing the necessary OTDR test adapter and updating the firmware on your device. True or false? So we'll leave that question up there for a minute, and we're going to get ready for a demonstration. So if you have a chance, go ahead and chime in on that next question. True or false, can you add OTDR capability to TestPro NSA by simply buying the adapter and updating firmware? Good question. So I am going to drop off of my slide here, and I'm going to share my camera view here. And we're going to, I forgot to change my power off setting. So now I'm going to have to reconnect to my OTDR. So while I'm doing that, when it's powering back up, I'll reconnect. But while I'm doing that, I'll just go through here real quickly with you what I've got in front of me. So these are the OTDR adapters. So I've got my, let's say I want to add it to my NSA. I've got my NSA here. I've got my PoE multi-gig adapter. I'm just going to take it out. And I'm going to take my OTDR adapter. And note, it's only got a single connector on it. And that's going to come with an SC. And I'm going to go ahead and insert the adapter. It recognizes it. I'm going to tell it, yes, I want to go into OTDR mode. It does a quick refresh, and it'll be in OTDR mode. So it's really as simple as swapping that adapter out into the NSA. And then, so that was the multi-mode. I've got a single mode adapter here as well. And additionally, I've got right here, this is our multi-mode launch cord. I don't have one of the single mode launch cords to show you, but that's the multi-mode launch cord right there. It's just a nice little compact package with some leads here that allow you to get some length away from it. But essentially the fiber is coiled up inside, and you've got 150 meters of launch cord. Now, talk about launch cord a little bit here. The reason that we would want to use a launch cord on a fiber is that in an OTDR trace, and I'm going to bring back the presentation for just a second here real quick. In an OTDR trace, like we looked at here, you might have an event that you want to see that might be too close in. So you want to get a launch cord to distance the end face of the tester from your initial connector, because you're not really going to be able to see what the loss is on that first connector without a launch cord. So that's why we use a launch cord. So I'm going to reconnect now that my tester is up, and we'll get our demo back on track here. I'm going to go into VNC mode. And then as soon as it comes up, I will pull up my app, and apologize for the delay. I should have remembered I had it powered up ahead of the show and forgot to set my my default power down to a longer timeout there. So it just shut down while I was talking away. So we're ready to rock and roll. I'll click connect, and it'll pull it right back up. And now we're ready. Now we've got the OTDR here. Now I've just got some coils of fiber here. Essentially, I've got a few 100-meter cords that I'm testing, so nothing really long or anything. So I'm going to go into my OTDR, and I'll show you a couple settings. Right now I'm set for 1310 and 1550. I've got a maximum length set at 500 meters, but you can choose from a drop down here and select pretty much whatever you need. And then same thing with the pulse width. You can do a click the menu. It'll pull the different pulse widths up. You can select or input your pulse width. And then I'm going to leave the test time at 5 seconds. You can adjust that up or down. There's also a live trace mode. So live trace mode is useful if you're connecting something and you're playing around with fibers. You've got an intermittent problem and you want to see if moving things around causes a change in the trace. You can do that. In our settings, you can go in and turn your limits on and off. You can adjust these limits. We put the defaults with a connector loss limit of 0.75 and splice at 0.3. You can edit these as you see fit. You can input your launch cord length and tail cord length in here, and then you can tell it to hide the launch cord trace if you wish. So I'm going to go ahead and run a test, and we'll see what we get reported back on the fiber I've got hooked up here. So I've got my launch cord, and then I've got a couple of 100-meter pieces of fiber, and then I've got a tail cord. So I can see here, I've got at the end here is I've got a tail cord reflection. I can pull up the event table of all these. I can look at this, and I can see in my event table, as I click this, here's my first event, which is the beginning of the fiber. Remember, I hid my launch cord, so I'm seeing the beginning of the fiber right there. And then we see the reflective event from that beginning of the fiber. That connector is shown there. We see our reflectance value and our loss value all within spec. We go to the next event and we see our cursor jumps to that next connector mating. It's about 100 meters away. And then we've got another one right out here at the last one, another 100 meters. So we're out at 200. And then here is the end of the fiber, which is that same event right there. That's the end of my fiber. Now you can look at it in this table view, or you can look at it in an event map. So when we look at the event map, here is the beginning of my fiber. And as I click each event, it shows what that is. And this shows me the start of the fiber. I click on the next event, and it shows me it's a reflective event. So I know that's a mated connector. I see my distance, it's right at the beginning of the fiber. So the distance is still 0. And my loss, I see my reflectance. I go to the next connector, which is another 98 meters out. I see the loss and the reflectance there. And then I go to the next event, which is going to be the very end connector on my fiber where it mates with my tail cord. And I see the reflectance there. and then I can click here and it's giving me the end of the fiber. So that's the table view. And you can switch back and forth between the 1550 and the 1310. I'll go back to the trace now. Now, one thing you'll notice, I did the test at 1310 and 1550. I see two traces here. One is sort of a more subdued trace. The other one is the brighter trace. So I'm on 1310 right now, which is that top trace. I'm going to click 1550. And now we see the screen change, and the top trace is more subdued. The lower trace is brighter. So that's showing you both traces at the same time. And remember earlier in the presentation, we talked about when you have a bend in the fiber, you want to be able to look at the two traces. You want to look at 1550 and look at 1310. If you have something that looks like a splice and it shows a lot more loss at 1550, that's typically going to be a bend. And that's why it's useful to have the dual trace. Now, the little chart at the top here, the A, B, C. So if we go back to my event table, I'm going to go back to the beginning of my fiber here. So our cursor's at the beginning. So when we look at these, A is going to be my first event. That's that reflection right there, that first connector. B is going to be the next one. I'm sorry, B is going to be the end of the fiber. And then the A to B is going to be the distance or the difference between the two. So it'll show you that total loss along that. So when we look at A, it's the first connection here. B is going to be my last connector. Remember, this is my tail cord, so we're not counting that. And you'll see that orange line right there showing us B. And then we save this test just like we would any other test. Before we show you the save, I want to show you, if you wanted to get more detail, you want to get more granular on this, there are some testers out there that have a pinch zoom. What we did is we do a drag zoom. So it's going to go a little slower on this VNC, this connection I've got with my computer, than it does on the screen itself. It goes much faster. But you're essentially going to click above and to the left of where you want to zoom in, drag down and right, and then you release it. It puts a little gray box there, and it zooms in just like I did that. So it just zoomed right in on that event. The reason we did the click and drag method instead of a pinch zoom is if you're using, you could use one finger, or if you're using a soft stylus, it's hard to do a pinch zoom with a soft stylus or a single finger. So doing the drag like that works a little bit better. And then, as I mentioned, we just save that event. We save that test rather, and then we can upload the test to our test results management software, TestData and in here you can generate your PDF reports. You can, so you'll have your PDF report that will give you all the additional information you need if you're doing that tier 2 test, or you're just doing it for your own edification, CYA kind of thing. And then the other thing that you can do in there is the detailed test, where we can actually put a marker on here. We can scroll on the fiber, look at the events, see how far out they are. You can also click on each event in the table to the right, and it will take you to each of those events. So those are the details there. So that is the AEM OTDR. So I am going to go back and take a look and see if we have some additional answers. So we've got more trues. Yep, I'm seeing a bunch of trues, which is great. True. If a customer invests in an AEM OTDR but has another vendor's kit as well, would they be able to import traces from another vendor's trace results because it is in an SOR format? Davey, I'll have to get back to you on that. I know currently we export to an SOR. We can export to an SOR. I don't know that we can yet import into TestData Pro, but I can tell you it's something we have looked into. So stay tuned on that one. But what we can export our OTDR traces from TestData Pro to an SOR, so you could pull those into another format. But I believe there's work being done by our engineering team on going the opposite direction. So stay tuned on that. Bunch of trues. We got all trues here. So everybody is hitting them out of the park. So I don't see any other questions. So I think we're just past that half hour mark in the episode. So if you have any questions, please feel free to visit our website, reach out to us. By now, our website is probably up and live with the new information that was happening as we were doing the show today. So this is all happening in real time. So hopefully everything went well with the website. You can go to aem-test.com and check out information on the OTDR. You can also reach out to us by emailing customer care at aem-test.com or sales@aem-test.com. Or you can email me directly, steve.cowles@aem-test.com. Reach out to us. We're here to help. We'll be glad to answer your questions. Appreciate everybody's time, and we'll see you back in a couple of weeks in the next episode.